Galaxies are enormous islands of stars drifting through the vast emptiness of space. Each galaxy can contain billions or even trillions of stars held together by gravity. Our own home galaxy, the Milky Way, contains more than 200 billion stars, along with enormous clouds of gas, dust, and dark matter. For centuries, humans saw only a tiny portion of the universe and assumed that galaxies were isolated systems scattered randomly through space. But modern astronomy has revealed that the universe is far more dynamic than we once imagined. Galaxies are not stationary. They move slowly through space under the influence of gravity. Over vast cosmic timescales, their paths sometimes cross. When that happens, two entire galaxies can collide in one of the most spectacular events in the universe. At first, the idea of two galaxies colliding may sound like a violent cosmic disaster, but the reality is very different from what people might imagine. Galaxies are incredibly large, yet the stars within them are separated by enormous distances. Even though a galaxy may contain hundreds of billions of stars, those stars are so far apart that the chance of two individual stars colliding directly is extremely small. In fact, when galaxies collide, most stars simply pass by one another without ever coming close. What actually drives the transformation during a galactic collision is gravity. As two galaxies approach each other, their gravitational forces begin to distort their shapes. Stars are pulled out into long streams stretching across intergalactic space. These structures, known as tidal tails, can extend for hundreds of thousands of light years. Massive clouds of gas inside the galaxies are also affected. When galaxies interact, these gas clouds can be compressed by gravitational forces. This compression triggers intense bursts of star formation. Regions that were once relatively quiet suddenly become stellar nurseries where thousands of new stars ignite almost simultaneously. Astronomers call these events starbursts. During a starburst, a galaxy can produce new stars hundreds of times faster than normal. Some of the most beautiful images captured by telescopes show galaxies in the middle of these cosmic interactions. Their spiral arms become twisted and stretched, glowing with the light of newly formed stars. The antennae galaxies are one famous example. Located about 45 million light-years from Earth, these two galaxies are in the middle of a dramatic collision. Long arcs of stars extend outward from their centers, forming shapes that resemble the antennae of an insect. Observations of systems like this allow astronomers to understand how galaxies evolve over time. A galactic collision does not happen instantly. Instead, it unfolds over hundreds of millions or even billions of years. At first, the galaxies slowly approach each other, their gravitational fields beginning to interact. As they draw closer, their shapes become distorted. Spiral arms stretch and warp. Gas clouds collide and compress, igniting waves of star formation. Eventually, the galaxies pass through each other. After this first encounter, gravity slows them down and pulls them back together again. Over time, the galaxies orbit one another in a complex gravitational dance. With each pass, they lose energy and move closer together. Eventually, they merge completely, forming a single larger galaxy. One of the most fascinating aspects of galactic collisions is that they are actually quite common in the universe. Many galaxies we see today are the result of multiple mergers that occurred over billions of years. In fact, astronomers believe that our own Milky Way galaxy was built through a long history of collisions with smaller galaxies. Evidence of these ancient encounters can still be seen today. Streams of stars orbiting the Milky Way are the remnants of smaller galaxies that were torn apart by gravity long ago. Even now, the Milky Way continues to absorb small satellite galaxies drifting too close. But the most dramatic collision in our galaxy's future involves the Andromeda Galaxy. Andromeda is the nearest large galaxy to the Milky Way, located about 2.5 million light-years away. Although that distance seems enormous, Andromeda is actually moving toward us at a speed of about 110 kilometers per second. Astronomers have carefully measured this motion and concluded that the two galaxies are on a collision course. The first major encounter between the Milky Way and Andromeda is expected to occur in about 4 billion years. When that time comes, the night sky from Earth would look dramatically different. Andromeda would grow larger and brighter over millions of years as the galaxies approached each other. Eventually, its spiral arms would stretch across the sky, becoming one of the most spectacular sights imaginable. During the collision, enormous tidal streams of stars would sweep across the heavens. Clouds of glowing gas would ignite new generations of stars. Despite the enormous scale of this event, the solar system would likely survive without direct harm. The vast distances between stars mean that our sun would simply continue orbiting within the newly forming galaxy. However, its orbit could change significantly. The solar system might be thrown into a different region of the merged galaxy. Over time, the Milky Way and Andromeda would lose their distinct shapes and merge into a single giant galaxy. Astronomers sometimes refer to this future galaxy as Milkomeda. Computer simulations suggest that the final result will likely be an elliptical galaxy, a massive, rounded system containing trillions of stars. Elliptical galaxies are common in the universe, and many of them are believed to have formed through exactly this kind of merger. Galactic collisions also influence the growth of supermassive black holes. At the centers of most galaxies lie black holes millions or even billions of times more massive than our Sun. When galaxies merge, their central black holes eventually spiral toward each other and combine into an even larger black hole. This process releases an enormous amount of energy in the form of gravitational waves, ripples in space-time that travel across the universe. In recent years, astronomers have begun detecting these gravitational waves, opening a new window into the study of cosmic collisions. Ultimately, galactic mergers are one of the most important forces shaping the evolution of the universe. They transform small galaxies into larger ones, trigger the birth of new stars, and redistribute matter across vast cosmic distances. The universe is not a quiet place where galaxies remain unchanged forever. Instead, it is constantly evolving through slow but powerful gravitational interactions. Every galaxy we see today carries the marks of past collisions, and every galaxy will eventually experience new ones. These events may unfold slowly by human standards, but over cosmic time, they are among the most dramatic transformations the universe can produce.